Fire emoji, a new frontier in space exploration. Once again, humanity has pushed the boundaries of what's possible, sending a machine closer to the sun than ever before. On December 24, 2024, while most of the world was celebrating Christmas Eve, something incredible was happening 93 million miles away. At that very moment, the Parker Solar Probe was completing its closest solar encounter ever, traveling at an unimaginable speed of 435,000 miles per hour, that's over 700,000 kilometers per hour, or nearly 125 times faster than a speeding bullet. Let that sink in. This tiny spacecraft, no larger than a compact car, became the fastest human-made object in history, flying through one of the most hostile environments known to science. But this mission is about much more than speed. It's about discovery. It's about bravery. And it's about understanding the most powerful force in our solar system, our sun. Sun with face emoji, diving into the sun's atmosphere. Sunday may look calm from Earth, but it's a churning ball of plasma, bursting with energy and chaos. The Parker Solar Probe is venturing into a region no spacecraft has ever entered before, the corona, the sun's outer atmosphere. Now here's the crazy part. The corona is hotter than the sun's surface, sometimes over 1,000,000 degrees Celsius, while the surface sits at just 5,500 degrees Celsius. For decades, scientists have wondered, why is the corona so much hotter than the sun itself? It defies logic. But now, Parker is helping us solve that mystery. On this recent pass, the probe came within just 3.8 million miles, around 6.1 million kilometers, of the sun's surface. That's about 1/10 the distance of Mercury's orbit. No other spacecraft has even come close. Wrench emoji, built to survive the inferno. To withstand this inferno, the Parker Solar Probe is protected by an advanced carbon composite heat shield capable of enduring temperatures up to 2,500 degrees Fahrenheit, about 1,370 degrees Celsius. Behind that shield, cutting-edge instruments are hard at work, collecting data on solar wind, magnetic fields, and solar eruptions. Its mission: to answer the biggest questions in solar science. Where does the solar wind originate? What causes massive solar flares and coronal mass ejections? And how does all of this space weather affect life here on Earth? These aren't just academic questions. Solar storms can disrupt GPS signals, damage satellites, and even knock out power grids. The more we understand our star, the better we can protect ourselves from its occasional tantrums. Rocket emoji, a journey years in the making. The Parker Solar Probe was launched on August 12, 2018, aboard a Delta IV Heavy rocket. Since then, it's been using a series of 7 gravity assists from Venus, slingshot maneuvers that gradually shrink its orbit, and allow it to get closer and closer to the Sun. The final Venus flyby took place on November 6, 2024, setting the stage for the December 24 record-breaking encounter. Each pass brings new opportunities, new data, and new risks. Satellite antenna emoji, silence. Then the signal because of the sun's extreme interference, direct communication with the spacecraft had to be temporarily suspended during its closest approach. NASA engineers held their breath, waiting for a sign, a small status beacon expected on December 27, to confirm whether the probe survived. If the signal comes through, it will be a moment of relief and triumph. The treasure trove of scientific data gathered during this flyby will be slowly transmitted back to Earth over the following weeks and months. Early analysis is expected by late January 2025, and scientists are eager to begin digging through the data. Shooting star emoji, and the journey isn't over. The Parker Solar Probe isn't done yet. It's scheduled for more perihelion passes, in March and June of 2025. The story of the Parker Solar Probe began not just in 2018, but decades earlier, in the minds of visionary scientists who dreamed of touching the sun. For years, the idea seemed impossible. The heat, the radiation, the proximity, it all felt too extreme. But thanks to decades of research, engineering breakthroughs, and international collaboration, this dream was finally launched into reality. On August 12, 2018, Parker took off aboard a Delta IV Heavy rocket, one of the most powerful launch systems ever built. Its destination: the blazing atmosphere of the sun, something no spacecraft had dared to approach. But it couldn't just fly straight in. To gradually move closer to the sun without being flung back out by its intense gravity, the spacecraft needed to perform 7 complex gravity assist flybys of Venus. These maneuvers acted like cosmic slingshots, each one bending the probe's path inward, decreasing its orbital distance, and preparing it for future close encounters. The final Venus flyby, on November 6, 2024, was the most critical of all. It precisely positioned the spacecraft for its historic December 24 approach, setting the stage for its closest and fastest flyby ever. Each of these flybys carries immense risk. But with each one, Parker edges ever closer to the sun's secrets, bringing back data that could transform our understanding of the cosmos. Satellite antenna emoji, silence. Then the signal as Parker made its record-setting plunge into the sun's atmosphere on December 24, scientists around the world watched with a mix of excitement and anxiety. During its closest approach, just 3.8 million miles from the solar surface, communications were intentionally suspended to prevent interference from the sun's radiation from damaging the spacecraft's systems or corrupting its data. In that moment, NASA engineers could do nothing but wait. The silence was deafening. No pings, no telemetry, no updates. Just the hope that the spacecraft had survived. Then came the moment of truth, December 27, 2024. A tiny beacon signal was expected to return to Earth, traveling across the vastness of space. That single signal would tell engineers whether the spacecraft was alive, or lost forever in the sun's fury. If received, it would mark a moment of triumph, signaling not just survival, but the successful collection of priceless scientific data. Over the following weeks and months, Parker would slowly transmit this treasure trove of information back to Earth. By late January 2025, the first analyses are expected to begin, and scientists are eager to uncover what Parker saw and felt as it brushed the edge of our star. Shooting star emoji, and the journey isn't over. This isn't the end, it's just another chapter in a story that's still unfolding. The Parker Solar Probe's mission continues into 2025, with additional perihelion passes, scheduled for March and June. Each pass will keep the spacecraft dangerously close to the sun, pushing its instruments to the limit, and collecting more and more groundbreaking data. Every orbit is unique. The sun's behavior constantly changes, magnetic fields shift, solar winds accelerate, and eruptions occur without warning. With each encounter, Parker faces a different environment, offering fresh opportunities for discovery. As the probe completes its final orbits over the coming years, it will continue to help scientists understand the fundamental forces shaping our solar system, and perhaps the universe itself. America's emoji. Why this matters to us now? You might be wondering, why should we care? Here's why. The sun is not just a glowing ball in the sky, it's the engine of life on Earth. But it can also be a source of danger. Solar storms, caused by sudden eruptions of energy from the sun's surface, can send waves of charged particles racing toward Earth. When